Yes, sir.
All right. So we will continue now. So today we will continue with the Rayleigh Ritz method. Okay. Till now we have covered two different cases where the point load was acting on the bar, and we have also seen how to deal with the surface loading. Okay. So today we are going to take one more problem wherein we will see how to take care of the self weight. Okay. So for this purpose we will take a simple column problem. Okay. So let me draw a column for you. uh, this is a simple column, you can say. Okay. And in this column, let us say we have a fixed support over here, and on this column there is a load of, let us say, 200 kilonewton is acting. Okay, so this is 200 kilonewton which is acting. Okay, now in the numerical itself the value of modulus of elasticity is given to you. So this modulus of elasticity is given as 2 into 10 raised to power 5 newtons per millimeter square. The value of area. Okay, so this particular column has got cross section area, and its area value is given to you as 5 into 10 raised to power 4. This is millimeter to the power 4. And the density, so this is made up of concrete, for example. So the density of the material of the column is given to you as, let us say, 25 kilonewtons per meter cube. Okay, now assume the length of this particular column as 3 meters, like this. Okay, so now we have to find out the we have to analyze the problem. We have to find out the displacement at, let us say, point of application of the load, and we will use Rayleigh Ritz method for this purpose. Okay, now in this case we have to consider two types of loading. Okay, one kind of loading is the external load. Okay, and the second one is the self weight. Okay, so the self weight of the structure is we have to calculate. So here the volume force will come into picture. Okay, so now let us solve this problem. Let us start over here. Okay, so here let us say solution, right? So now here first thing is we need to understand that the your total potential energy, that is pi, is the summation of u, that is the strain energy, plus the work done over here. Okay, now in order to calculate the strain energy u, what expression we are writing? Anybody? क्या होता है strain energy? Yes,
P square L.
sorry, कोई बताओ. So it is something like A E divided by 2. This is integration over the length, isn't it? Then we have du by dx whole square into dx. So this is the simple expression of strain energy. But in order to calculate the accurate strain energy, you should know what is the value of u. Okay. So in the Rayleigh Ritz method, what we generally do, we assume the relation, or we assume the expression for u, and if your assumption is not appropriate, your results are going to change. Okay, so in this today's class we will assume some higher order polynomial. We will not go for a lower order polynomial. So let us write u as a function of a0 plus a1 into x plus a2 into x square. Okay, so I am using the second order polynomial over here. Okay, so now if I use this, so I need to calculate the strain energy, and for this purpose I should know the constants, that is a0, a1 and a2. I should know those values. Okay, so now let us first of all draw the free body diagram. Now remember this is a column problem, and what we can do is in place of writing the straight line, in place of going for the vertical straight line, I am going for the horizontal line over here. Okay, otherwise you see your column is vertical one, right? So what I'm going to do over here is this is my starting point and this is my ending point over here. Okay, so I'm going to consider only two nodes over here. So this is node number 0 and this is node number 1. Okay, as far as axis is concerned, I'm considering this as the origin and this side is my axis. Okay, so axis is like this. Okay, now if you consider this as the origin, so here your x will be called as x0 and its numerical value will be 0, and here x will be called as x1 and its numerical value will be 3 meters. Okay, so I am intentionally writing meters because other values like modulus of elasticity and cross section area, even these two values they are in mm. Okay, so I am writing in meters. Okay, now as far as the deformations are concerned, so this will be called as u, and this since it is at point number 0, so this will be u0 and its numerical value will be 0. Why I'm writing numerical value as 0? Because this is that point, so this is the support over here. Okay, I have drawn the 90-degree rotated view of the column over here, so here the displacement will be 0. Okay, now as far as this part is concerned, we have u, this will be called as u1 and the value of that u1 will be unknown. Okay, because this is not known to me. As far as loading is concerned, we have a loading which is coming to this point. Okay, so there is a load which is coming like this. Okay, its value is 200, this is kilonewton. Okay, so it is acting exactly opposite to the direction of the axis which we have assumed. Okay, again I am repeating, it is acting in the exactly opposite direction of the axis which we have assumed. Okay, so this is a free body diagram of the bar. Now let us try to find out the unknowns over here. Okay, so for this purpose, what we generally do, we first of all go for applying boundary condition. So if you apply the boundary conditions, what is going to happen? So let me slightly go down over here. So I'm writing something like at, okay, at point 0. Okay, so if this point is 0, your x will be x0 and its numerical value is 0. At the same time, u is u0 and its numerical value is also 0. Okay, and what we have assumed earlier, u as a0 plus a1x plus a2x square. So if you substitute both the values in this expression, so this will be 0, this will be a0 plus a1 times 0 plus a2 times 0 square. So this is going to give you the value of a0 as 0. Okay, so finally your displacement function will remain something like a1 into x plus a2 into x square. Okay, so let us call this as expression number 1. Okay, so we have removed one of the constant because its value is now 0. Okay, so now if this is the case, I can easily go for the derivative of this particular expression so that I can get the value of du by dx. So this is du by dx will be, so if you go for derivative of this, so this will be simply a1 into 1, because d by dx of x will be 1, and here you will have a2 and this will be 2x. Okay, so your strain, okay, that is du by dx, so du by dx now can be written a1 plus 2 times a2. Okay, so let us call this as expression number 2. So this is how you can get the value of du by dx. Now coming to the strain energy part. Okay, so this is strain energy. Okay, so this strain energy can be written by a simple form, that is u equals to a e divided by 2 integration over the length, then we have du by dx whole square into dx. Okay, so now we need to know what is the value of ae by 2. Okay, so now we have different units in the problem. We have something like e as 2 into 10 to the power 5 newtons per millimeter to the power 2. Area is so and so. Okay, so what we require something like ae by 2. Okay, so if you convert this into say into a meter square kind of a thing. Okay, So your E value, so let me use some different plane. So your E value initially it is 2 into 10 to the power 5. This is Newton per millimeter square. So if you go for its equivalent, in that case you are going to get something like this is 2. I think it is 200, okay, into 10 to the power minus 6, okay. uh, this is kilo newtons per meter square. Am I right? Is it correct? Somebody please cross check this. Somebody please cross check this. Is it correct? Yes. Is it okay? Yes, somebody please respond. अरे सो गए क्या सब लोग?
यस सर.
सो गए?
नहीं सर.
ठीक है, तो ये कन्वर्शन बराबर है.
हाँ सर.
All right, fine. So this is I am converting everything into kilonewtons and in meters. Okay, so we have converted E as 200 into 10 to the power minus 6 kilonewton per meter square. And if you talk about this area, so area is 5 into 10 to the power 4 millimeter to the power 2. Okay, so if you convert this into meter square, so this is going to become something like 5 into 10 to the power minus 2. This is meter to the power
सर
2.
सर वो ई में माइनस नहीं 6 नहीं आएगा
Sorry,
सर इन द वैल्यू ऑफ
सर ई रॉन्ग है
सर 6 सर नॉर्मल 6 रहेगा वो.
okay, it is not negative. Okay,
It should be
sorry.
6.
Fine. Okay, so this is AEA values. So here if you see, here I need to have the value of AE divided by 2. Okay, so let me do some calculations over here. So I just need to go for A into E divided by 2. So this is something like area. Let me write down the E value first. So this is 10 to the power 6 multiplied by 5 into 10 to the power minus 2 whole divided by 2. So can somebody tell me what is the value of AE by 2? Yes, this will be cancelled, isn't it? So this will be something like 5. Okay, this is
5
8
into the power 6
into 10 to the power 6. Okay, and what will be the unit? Anybody? This will be in kilonewtons, right? Because this meter square and meter square will be constant, will be gone. Okay, so we have the value of AE as 5 into 10 to the power 6. So the same value I am going to write down over here. Okay, so let me write down these values. Okay, so here this U now can be written as simply 500 into 10 to the power कितना आया था ये? I think it is 10 to the power 6, right? All right, so 500, oh sorry, not 500, 5 into 10 to the power 6. Okay, uh, okay, so this is 5 into 10 to the power 6. Okay, integration over the length now. Okay, so now if you go for integration over the length, we have to go for du by dx. Okay, so du by dx just now we have calculated over here. Okay, so this can be written as a1 plus 2 times a2 whole square into dx. Okay, so if you expand this, so this length, the length value is basically 3 meters, isn't it? So I can rewrite this as 5 into 10 to the power 6. Integration over now 3 meters I am writing over here. So this is something like a1 square plus 2 times, so this will be 4 times a1 a2 plus 4 times a2
Sir,
square
in terms of
into
du by dx,
dx.
next term
Okay,
will be
I
this
hope this is clear.
multiplication of it.
Sorry,
So,
sorry.
the value of du by dx, it should be 2a2 into x.
Yeah, sorry, my mistake. Huh? This is a2 into x. Sorry. Huh? This is 2 times a2x, right? So this changes everything. Okay, It's good that you are attentive. So I will have to rewrite the entire part now. So only thing is some portion will be now changed. Okay, so this is x. Okay, 4 times a1 a2 into x plus this is 4 times a2 square and x
Yes,
square.
sir.
I hope this is correct now. Okay, right.
Yes.
So now if you go for the integration part, so you will get something like over here this is 5 into 10 to the power 6. Okay, and here so this a1 square will remain as it is. Okay, and the integration will be only x, where x will be from 0 to 3. Okay, plus 4 times a1 a2. So this x integration will be x square divided by 2. This will be again from 0 to 3 plus 4 times a2 square, and this is x square will be now x cube divided by 3. Again this will be from 0 to 3. Okay, I hope this is correct. Well, all right. So now if you substitute the values over here, actually today I don't have the solution, so I have to solve it. Okay, so this is 5 into 10 to the power 6. So this will be something like 3 times a1 square. Okay, so here this 2 and this will be cancelled. So this will be 2 times a1 a2, and this will be 3 square. Okay, so 3 square will be 9. So 9 into 2 is nothing but your 18. So in place of this 2, now directly I can write down over here as 18. Okay, plus we have this as 4. So I'm taking out 4 by 3 outside. We have a2 square, and 3 is a 9. 9 into 3 is 27. Okay, so this becomes 27. Okay, so if you go for division of this, so this will be 9. Okay, so this will be something like 9, and rest will be 36. Okay, so let me rewrite all this thing. So all we have over here is
Yes, sir.
36. Is it correct?
Yes.
बराबर है ये?
Yes, sir.
So this is the expression for the strain energy. Okay, now comes the most important part, that is the work done. Okay, now remember this work done is having 3 components. Okay, so work done is having, let us say, point load. Okay, plus we have surface load. Okay, plus we have volume load. Okay, so now in our case this surface load is not at all there, point load is there, and volume load is also there. Okay, you can see over here point load is acting over here, that is 200 kilonewton, and volume load is nothing but your self weight, so it is also there. Okay, so this component will not be considered. So here if you write the expression over here, there is only one point, so here you have u multiplied by p. Right, now this u and p, so it will be acting at which point? So you can see this is acting at point number 1. If you refer the free body diagram, this is acting at point number 1. So here I'll be needing u1 and p1. Okay, and of course this will be minus because work done is considered as minus. And as far as volume load is concerned, you have to go for integration over the volume. You have u transpose multiplied by fv into dv. Okay, so now we will start slowly how to get these values over here. Now the very first thing what we require over here is u1. Okay, so u1 is the nothing but the displacement at point 1. Okay, so this is displacement at point 1. Okay, now if you refer your expression number 1, okay, so this expression number 1 gives you the displacement. Okay, so this u, okay, so if you write down over here, u is nothing but a1x plus a2x square. Okay, so this is the expression for u. So now if you are at point number 1, so if you are at point number 1, this will become u1 equals to a1. What is the value of x at point number 1? So at point number 1 the value of x is 3 meters. Okay, so let me write down over here, this is nothing but 3 meters. Okay, plus A2 into 3 square, okay, x square, so this will be simply 9. So this is the expression for U1. Okay, and what is your P1? P1 is nothing but your load. Okay, and this P1 is its value is 200 kilonewton. Okay, this is 200 kilonewton. Now one thing you need to understand over here is this 200 kilonewton load is acting not in the direction of the axis, it is acting exactly opposite to the direction of the axis which we have assumed. So for this purpose, the value of P1 should be considered as negative. Okay, remember when we have solved the problem on the first class. Okay, so that time the problem was like this. Okay, and here the load was acting like this, and our origin was over here. Remember this? So this side we have x and this side we have p. So at that point, at that time, what we have done, we have considered the work done at this point. Let us say this is point number 1. So we have considered u1 and p1 both as negative. So here we have substituted the values, but this p value we have considered this as positive. Okay, why? Because this is in the same direction, but here it is not in the same direction, it is in the negative direction. Therefore it has to be considered as negative 1. Okay, I hope this is clear to everybody. Yes, shall I proceed? बेटा समझ में आया नहीं
Yes,
आया?
sir.
All right, so let me take the first part, that is the point load part. Okay, so your point load is minus, this is u1. So u1 we have calculated as 3 times a1 plus 9 times a2. Okay, so this is your u component. Okay, multiplied by your p component is minus 200. So if you solve this, all you are going to get is a simple expression. So this becomes something like, this is negative, this is negative, so this will be of course cancelled. So 3 into 200, that comes out to be 600 times a1 plus this is 800 times you have a2. I hope this is clear to everybody. ठीक है? Is it okay? Okay, so I'm continuing now. Now coming to the other part, that is the volume load. Okay, so now the volume load is like this. Let me slightly go down. Okay, so volume load is integration over the volume. Okay, this will be something like u transpose into fv over dv. Okay, now what is my u? Just now we have seen the value of u is this. Okay, so this is your expression number 1. Okay, remember this was your expression number 1. Okay, same thing I am going to substitute over here because it has to be calculated over the volume. So I am writing down volume over here, and your u transpose will be the same as a1x plus a2x square. Okay, now this, what is fv? fv is nothing but the weight or the force over the volume. So this is nothing but your density. Okay, so density is what? It is nothing but a weight per unit volume, isn't it? So this density we have been given as something like 25 kilonewtons per meter cube. So I am going to write down over here this as 25 only, because everything is in kilonewtons and meters. Okay, so in the numerical itself, in the beginning, it is written as 25 kilonewtons per meter cube. So this value will be now 25 kilonewtons per meter cube over dv. Okay, now what is dv? Okay, so generally we write volume is nothing but area multiplied by length. Now you see this area is constant. Okay, so if you go for dv over here, so dv will be nothing but, since area is constant, so this will be dx now. Okay, because if you integrate x, you are going to get the value of x, and if you integrate over the length, so you are going to get the value of L over here. Okay, so here the cross section area is given to you, isn't it? So this cross section area is already known to you. So this cross section area value is 5 into 10 to the power 4. Okay, so this 5 into 10 to the power 4, that can be written over here So this expression, so this is integration over the length now. So this will be a1 into x plus a2 into x square into 25, and this will be now area. Okay, so what was the area value? I forgot one more time. So area value is 5 into 10 to the power minus 2 meters square. Okay, so this is 5 into 10 to the power minus 2 over now dx. Okay, so since this is dx, now this will become dl. Okay, so now how much is this? 25 into 5. So this is 25 into 5 to the power minus 2. Okay, so this comes out to be 1.25. So this 1.25 will come out, and this will be from 0 to now 3, because the length is 3. So this will be a1x plus a2 x square over dx. Okay, I hope this is clear to everybody. So now if you go for the integration part of this, so all you are going to get is something like 1.25 into, this is a1, so x will become x square by 2. So this will become x square by 2, and if you go for substitution of x, so x will be from 0 to 3. This will be a2, this will be x to the power 3 upon 3, this will be 0 to 3. Okay, so this will be the integration part. Okay, so now let me go for this. So this is this 9 times a1 divided by 2. So this will be 27, 20 yeah, 3 to the power 3, and this will be divided by 3, so it will become square. So this will be something like 9. Okay, 9 times a2. Is it correct, everybody? Yes, is it correct?
Yes, sir.
Okay, so if you even simplify this, you can take out 9 common and multiply it by 1.25. So this is going to give you something like 11.25 multiplied by now a1 plus a1 divided by 2 plus a2. Okay, so this is a simplified expression for the work done. Okay, now this work done is only for the sulfate. Okay, so sulfate, so let us call this as ws. Okay, or wv rather, not surface. This is a volume load, so we have to go for work done due to the volume, and here this is due to the point load. So the total work done, so total work done will be the summation of this. Okay, and of course this everything will be going in the negative side, right? So now let me write down directly the potential potential energy equation. So this potential energy equation, this total potential energy pi will be u plus w. Okay, so your u, so just now we have seen this is our u value. Okay, so this is 5 into 10 to the power 6. Okay, so let me write down over here. So this is 5 into 10 to the power 6 into we have 3 times a1 square plus 18 times a1 a2. So this is 3 times a1 square plus 18 times a1 a2 plus I think we have 36 a2 square. So this is 36 a2 square. Okay, so this is u. Now w, it should be taken as negative. So the work done due to the point load is this. Okay, that is 600 a1 plus 1800 a2. Okay, so this is something like 600 a1 plus 1800 a2 minus, then again this is due to the volume load. So due to the volume load, it is something like this, that is 11.25 into a1 by 2 plus a2. Okay, so now this is nothing but your total potential energy pi. Okay, I hope this is clear to everybody. Is there any questions? Yes. Okay, so I'm assuming there are no questions. So now in this case you have two terms or two unknowns over here. One is a1 and one is a2. Okay, so in order to get the equilibrium, the del pi by del a1 should be 0, and at the same time del pi by del a2, this should be 0. Okay, so you will get two expression over here. This is expression number 1, this will be expression number 2. You have to solve this. Okay, so everybody please solve this and tell me what is the value of a1, and please tell me what is the value of a2. Today I don't have the solution, so you have to help me. Okay, please solve this and let me know the values of a1 and a2. Please do this. Let me know when you are done. Yes, anyone value of a1 or a2? Yes, anybody has solved? Yes, anybody? Please tell me the value of a1 and a2 after solving.
Sir, A1 is equal to 2.031 into 10 to the minus 5.
Okay, just let me note down. How much is the a1 value?
2.031 into 10 to the minus 5.
Minus 9. Okay, and
5.
5. Okay. Okay, and how about this one, a2?
Minus 4.44 into 10 to the minus 8.
Minus 4.44.
44
Okay.
into 10 to the minus 8.
Minus 8. Okay, it's a very small value. All right. Fine. So now, if is there anybody who can confirm these values, or shall I continue with this one? Anybody getting similar values? Or you want some time to do the calculation part? We'll wait for a minute, then we'll start. Okay. Yes, shall I continue? Yes, students, shall I continue?
सर A2 की वैल्यू -6.25 इंटू 10⁻⁻8 आ रही है.
Yes, sir. -6.25.
-6.25 10 to the power
-8.
-8.
और फर्स्ट वैल्यू भी मतलब 2.0375 near about same.
2.03 and 10 to the power 5 is correct, negative?
Yes, sir. -5.
Okay. So let us consider this value because there are two persons who are confirming this value. Okay. Let us discard this value. Okay. So I'm continuing now because I have to complete the problem now. Okay. So all I wanted to tell over here is now the final value of u. Okay. So u is initially a1 into x plus a2 into x square. So if you write these values, so you can have something like this is 2.03 only I am writing over here into 10 to the power -5, this into x plus, okay, so I'm putting x into bracket, and then in place of plus I should write minus because the a2 value is negative, so this is minus 6 sorry 6.25, okay, so this is 6.25 into 10 to the power -8 into x square. Okay, so this is the value of displacement function. Okay, so you see these are more realistic values because as the value of x is changing, your displacement is also changing over here. Okay, so now I am drawing the column over here now. Okay, because earlier if you remember, this was not a bar problem, this is a column problem. Okay, so if you see the column, your column is like this. Okay, and you have origin which is over here, so this is your x0, its value is 0, and this is your x2, oh sorry, x1, and its value is nothing but your 3 meters. Okay, so now if you see the variation of displacement over here, so at this point your x value is 0, so here if you substitute the values of x as 0 over here, okay, so you won't be getting any displacement at this point, so this will be remaining over here. Okay, and if you substitute the value of x over here as 3, okay, so let us substitute this as 3, so what is going to happen, so this is 2.03 into 10 to the power -5 into 3 minus 6.25 into 10 to the power -8, and this will be 3 square, so 3 square will be 9. So can someone tell me the value of u over here, please?
6.03 10 to the power -5.
Sorry, one more time please.
6.03
One more time please. 6.03
10 to the power -5.
-5. Okay, and this will be of course in meters. Okay, because everything is going in meters over here. So since this is positive, okay, whether it is positive or negative, please check. I think it should be negative.
Sir, positive.
पॉजिटिव नहीं आना चाहिए बेटा, नेगेटिव आना चाहिए. Okay, because you see this is there is a load which is acting like this, and your self weight is also acting like this. So if this is your positive x value, okay, because you remember this was your origin, okay, so your this is positive x, okay, so your value of u should be negative. Okay, anyway, I think there is some calculation mistake, or probably the values some difference with the values. So here you see ideally what should happen, this point this should go down, okay, because of the influence of the force. So this is the displacement which you are getting over here. Okay, so if you plot a curve of displacement, if you draw a straight line, okay, so I am talking about this one, so here this will be second degree polynomial. Okay, so as you move from this point above, so your displacement is continuously increasing, okay, or it is continuously compressing, because as you move from bottom to the top, what is happening is your load is going to increase. That's why you are getting this kind of forces or this kind of variation of displacement over here. Okay, now if you talk about du by dx, okay, so this is nothing but your strain. So if you go for du by dx, so this will be something like this is 2.03 2.03 into 10 to the power 5. So this will be x will be gone, and here this will be x square. So this will be 2 times. So 2 into 6.25 into 10 to the power minus 8 into x. Okay, so this will be a straight line relationship. So here if you put the value of x as 0 over here, okay, so this will be 0. So you are going to get this much amount of strain. Okay, so if you draw a strain diagram, so this is a strain diagram. So when x equals to 0, you are going to get some strain. Okay, so this some strain is nothing but 2.03 into 10 to the power 5. Okay, but if you put here x value as 3, so in that particular case this value will become 3. So this is 2.03 into 10 to the power 5 minus 3 into 2 into 6.25 into 10 to the power 8. How much is this? Someone please tell me. Yes, somebody please tell me. कितना आ रहा है? Yes, someone please answer. How much is this? Or shall I do it? कितना आ रहा है?
1.99 in 10 raised to power minus 5.
1.99 into 10 to the power minus 5. Okay, so your strain is slightly reduced. Okay, so as you move away from the bottom, तो जैसे जैसे आप ऊपर जाओगे तो आपका लोड कम होते जाएगा, तो strain of course it will be reduced. Okay, so this is very logical over here. As far as your stress is concerned, your stress is simply E multiplied by strain. Okay, so the value of E is already known to you. Okay, so value of E, if you remember, we have calculated this. Okay, so we have calculated over here. So this is 200 into 10 to the power 6. Okay, so here this E value, this is this will be 200 into 10 to the power 6. Okay, this should be power term multiplied by, you have this strain component. Okay, so your strain component is nothing but 2.03 into 10 to the power 5 minus 2 into 6.25 into 10 to the power minus 8. Okay, multiplied by, now you will have either 0 or 3. Okay, so this is x. Okay, so you have to substitute the value of x, and x as 3 as well as x as 0. So you are going to get a very much similar figure over here. This will be again a straight line like this. Okay, and you will find the stress is more at the bottom and this is at the top. Okay, so this is bottom. Okay, so if you substitute the values x as 0, what stress you are going to get? So this will be 0. So this will be same as this value. Okay, multiplied by 200 into 10 to the power 6. Okay, how much is this? Somebody please tell me. This is minus. Okay, I think I have made mistake in writing. This should be minus. Okay, so please make correction. This should be minus. Okay, this should be also minus. This should be also minus. Yes, somebody please tell me. कितना आ रहा है?
4060.
Stress. Sorry,
4060.
4060. Okay, so this will be kilonewton per meter square. And how about over here?
3985.
3985. This will be again kilonewton per meter square. Okay, so you can see this is the distribution of stress in the column. So at the top there will be a stress which is only due to the concentrated load. Okay, and as you move down, so your self weight will start coming into picture, and because of that you will find the stress is more at the bottom. Okay, so I hope you have understood this particular concept, wherein how to take care of the self weight is shown over here. Okay, so is there any questions? No. All right then, so we will